I will unmute myself. Can you hear me? Hello? Can you hear me? Yes, sir.
Who steps into those states for APC?
Yes, sorry, there is a technical problem here, so I have to fix it.
14 days now. Whereas
I'm making noise. Let me.
10 days, we don't wish to complete all the primaries. In fact, this quarantine will be a very good thing.
Sorry, Dr.
We are
Duro.
back. We are back. Please.
Hello.
Hello, we are back. Yes.
Are we?
Yeah, we are back. Yes.
Because I'm only, it's like it's Oji Sunday that is now chairing the meeting.
No, some people are just, okay. Can you hear me
now?
Yeah.
Yeah, I can hear you now.
Yeah.
Initially, you were not even there at all.
And then what really happened, this thing went off, my internet connection, so I have to resolve it. Are we together now?
Yes.
Yes, let's continue, please. We'll go on now. Let's continue. Yes. Okay. Annotation. Yes. I think I was about to talk about the linear regression. I'll talk about correlation as it's an association between two degree of association between quantitative variable. That's one thing. On both sides, it's quantitative. And there's no outcome, no exposure. It's just an association between two variables. You cannot say one is leading to the other one. Even if you feel better, that's not the logic behind it. So, and even if it's not for non-para, you can use for non-parametric, even if that thing did not have number before, like a ranking, ordinal scale, you can use it. In that case, it's non-parametric, it's rank correlation. So let's go to the next one. This one, regression, there is a relationship now. In regression, you can talk about dependent and independent variable. So there will be a variable that is depending on one or more than one variable. That's one thing with regression. So, in all these kinds where all those one is t-test, one outcome, one exposure. It's only in ANOVA, when they are talking about factorial ANOVA, you can have one outcome, many exposure. With the same thing as a regression. I told you ANOVA and regression is actually the same thing. So you can have one outcome and many exposure. You can have one outcome and one exposure, it doesn't really matter. So the one outcome and one exposure in regression is like one way ANOVA. While one outcome and many exposure in regression is like factorial ANOVA. Now, this one, when the outcome is quantitative, that is, the outcome can follow normal distribution as a continuous variable. It's called linear regression. The exposure, what are the independent variables doesn't really matter. It can be quantitative, it can be categorical, it can be anything. So in linear regression, the outcome is continuous, while the exposure can be anything. Before people think the exposure has to be continuous, so it doesn't have to. The advancement it needs that the outcome is the continuous, the exposure can be categorical. So you can have more than one exposure. Some can be categorical, some can be continuous, some can be quantitative. All of them can be quantitative, all of them can be categorical. That's one thing with linear regression. While logistic regression, the outcome is categorical. The outcome is categorical. Just like the other one, the exposure can be continuous and the categorical can be. So what defines them now is the outcome. You see, and each of them is only one outcome. But we can have one exposure, you can have many exposure. So when you are talking of one outcome, one exposure, it is simple regression. When you are having many exposure, it is multiple regression, like factorial ANOVA. So The one that you look at is linear regression, that is the same thing as ANOVA. It's not logistic regression. So, but the logistic regression is for outcome that is categorical. And so even the logistic regression, the outcome can be ordinal sometimes. If it's two category, binary logistic regression, there are two, the outcome is only can divide into two categories, like the clinician like it a lot. Treated, not treated, discharged, not discharged. You know, two particular outcome, logistic regression, where you can have many exposures here. I think we stop here. That's just the overview of hypothesis test. So let's give room for question. So let me quickly look at if there's any. Oh, I don't know if anybody has sent test before, because that one has gone. I have to go and open the file to see. I don't know if anybody has chatted, sent any question before. Let me see. I'm seeing question now. Can we have a review of both linear and logistic regression, please? It's not very clear. Okay. Now, what is serial ANOVA? What is serial ANOVA? Serial ANOVA. Serial ANOVA. I don't know what you mean by serial, unless if it's is it factorial ANOVA you wanted to see. Serial ANOVA. I don't know. I've not heard that. Please, can we be quiet? Okay, can be quiet. So let me quickly. I don't know if anybody sent. Let me see if I can see that file. Where it is. See the file. Yes, I can see it. Let me quickly. Okay. So you can ask. I will answer the question of Dr. Bello. But if you have any question, you can ask now. If anybody has any question, I will answer the question. Any other question?
Please, I have a question. Well done, sir.
Welcome. Welcome. I'm listening.
Okay, sir. Sorry, sir. Okay. You. Thank you very much, sir, for this lecture. My question is: I've seen some, like, tables where, for example, if you want to do a chi-square, let's say for age, and let's say you're doing urban rural, and you have tables of age, and for age you can do a T for age. Use T, that is, do the T test.
Yes.
Yeah, you can also take chi when you convert.
Yes.
If you categorize age, yeah.
Okay, go on.
So my question is, can you put two of them in your results table? For example, when you do like a categorical.
Okay.
When you
need to tell me that is the result I sent to you is like that. Okay.
You know why I'm asking? Because I want to know what to say. Like if I had to defend it, because that's the way I put it. Like that's the way I liked it, but I feel like as if I do, because like you said, the organs, they might have different ideas about things. But like I like the way that you can put it that way. So my own is that, like, what can one use to defend that? Like why did I put it that way? Because I like it that way, but I've been looking for a reason, because I liked how
it was. That's a question of what I like,
Okay. The issue there is that if you look at it, both of them are saying different things. So
yes,
your mean, when you compare the mean, the t-test, it's comparing the value, raw value, comparing urban rural, raw value.
Yes, yes.
When you have categorized it, it's no more it's age group now, it's not age the raw like that. And mind you, the same data, another person can have the same data and categorize it differently from your own. The way you range it may be different. You get the vision. So when you compare the category, sometimes the category there may be you may not have significant difference, or you may have significant difference in the category, or you may not have. and whereas in the T, you may not have significant difference. Do you get the picture? So
Yes.
what people cannot understand is that the age group is different from age. You know, outside the country, most of the time when they compare, they don't even like categorizing. They take the value the way, because when you categorize, you lose some information. And if you categorize, there are different ways you can, infinite number of ways you can categorize. Some people can use interval of 10, some can use interval of 2, 5, you know, even though some may be close, you discover that the same thing, two people may not categorize the same way. So if you get the same fair result, but when it is mean, you comparing the mean, it's the same thing. If it's the same data set, it's the same thing. You get it? So it compare the mean directly, whereas the other one compare the category. There are two different things. So that's why I usually put it. So, and the way to interpret it is that this, when you are seeing difference between the category, you now say the category, you can actually track it to know where the difference lies in the category. So whereas the other one give you absolutely, and sometimes you can have both of them can be significant. Why one may be significant, the other one is not significant. So it depends on you. So it depends on the knowledge. But I understand what you are, because there are some examiners that, you know, sometimes it's better not to be informed than to be half informed. Some of them are half informed, and by the time they keep on, you know, I've seen people that feel someone that did the right thing. They have the power. And so if your supervisor says you should remove it, you remove it. That's why your supervisor first when you are going for exam. So when you go for the exam, you assessor. When you now go for exam now, you assessor the result. You know, it's the same thing with your proposal. Your supervisor first. When the proposal go to the assessor, whatever the assessor wants. When you do the result now, your supervisor, whatever he advise you, especially if it's part of the examiner, because sometimes even if you are right, if it's not, it doesn't really matter, because if you don't comply with what he has to, by the time they say, I told her. So when they are doing the exam, say, I told the there is not listening. So that's why you, you know, you do it the way they want. It is when you have passed, you can do the right thing, you think it's the right thing. That's just it. So if they do, so sometimes they say you should turn it upside down, you turn it upside down. But sometimes you have to pray, because sometimes your supervisor says you should do something that is not good, and you did it, and your assessor will not capitalize on that. But if you say your supervisor, no, it's your work, don't say your supervisor. Can you see the way they play devil's advocate?
Yes.
So let's just continue. So sometimes that's why I don't give my word emphatically, because I'm not your assessor, I'm not your supervisor. If I feel something right, it doesn't really mean that you have to, because if the person that want to pass you, that's their own territory. To pass your field is not my work. It's their own territory. So you have to dance to their tone. It's good for you to know how to defend. So whenever you are defending an exam, what you should do is this. Anything they are saying, they say this, oh, thank you, sir. Thank you. If they say something that you feel like you are not, thank you for this thing you raised, sir. Oh, man. You know, this thing came when we are doing the analysis and presenting, you know, many opinion, advice, all those are now decide you give this thing like this. You know, you reason with them. So they know that you know what you are doing. If there's anything that they did, they say it's all right. Thank you, sir. If they correct you, oh, thank you, sir. But if they say something that is, you know, that they are not right, there's a way to say, oh, thank you, sir. Thank you, man. However, the reason you now give background why you did it like that. So it's proof that you did the work. Because sometimes you can even, if you are right, most of the time you have more than one examiner. The other person may sense that you are right. You know, sometimes in exam you can let the supervisor know their stupidity without telling them they are stupid. They just in a polite way. You say, oh, sir, that's why I say this one. Okay, that's okay, no problem. So that they will not fail you, because if you try to prove a point, they say, can you see, very arrogant. Whereas they are the ones that are wrong. So in exam, it's only in Africa that teachers always know more than students. It's not always the case. It's not, you know, that is the problem we have with black. Teacher always know more than, but if you have done the research, in fact, you know more than your teacher in that area, especially if that particular topic, you are the one that's why you have spent the last 1 or 2 years researching. You discover that you may discover a lot of things, more than even your professor. But it takes humility to know that that is the way it is. In fact, your teacher is supposed to learn from it. But here, the teacher know all, the student don't know anything. So let's continue. So you have to be careful. You have to be careful when you are in exam so that they will not fail you.
Okay.
Okay?
Thank you very much, sir. Thank you.
Yes, I'm reading. I'm still coming back to Doctor. I'm trying to read the question posted before that thing went up. I'm still coming back. I've seen it. What is it?
Can I ask now?
Okay.
Can I ask now?
Okay, you can ask. Okay, you can ask.
Oh, thank you very much for the talk. My question is with respect to violation of assumptions for parametric tests.
Okay.
Can you hear me?
I can hear you, sir.
Can you hear me? Okay.
I can hear you. I can hear you, sir.
Okay, you said when we use tests that are that assumption of normality, and then you give example of robust tests. My question is, how do you determine that a particular test is robust or not robust, such that if there is a violation in the assumptions of normality or parametric, you can do any of those things, either transform or use the non-parametric and so on. So the simple question, how do you say that a test is robust? How is it determined? Or is it predetermined by authors already?
Thank you, sir. Thank you, sir. No, that's a very brilliant question, sir. You see, what I would advise is, I myself, I don't have, unless I search literature, I've seen where I can give you a reference anyway. So what you can do to try to reference, because you know, it's just like when you say theoretical distribution. It's something that some people, they are proven it, but you now believe it. So you now reference. That's the beauty of academic. You reference a particular authority. Yes, ma'am. So, you know, I told you of two tests that are considered to be robust. T-test and ANOVA. So all you need to know is to have a reference that these are robust tests. That if something, like for example now, you've seen a situation where somebody, they used like SK, all these 5K, 1, 2 to 5, all these strongly agree. And if the sample size is so large, you can still do t-tests. Yes, I mean, to compare the score. Because the reason is that when you are now having a lot about 300, when you are calculating mean, the mean will come in decimal. You know, the other one is 1, 2, 3, 4, 5. Is a discrete variable. Ordinarily, with some the score you just give arbitrarily. But when the class is large now, by the time you calculate, you can even the mean will be adding decimal. So, and if you are adding the scoring, it can give you a composite score. Which you can use t-test to do, because t-test and this and over they are robust tests. So all you need to do is to look for a literature, a standard literature to back it up. You reference that these two tests are robust. But you have to be careful when it comes to exam, because I mean, if it is published, there's no problem. If you want to publish, or somebody refuses to publish, you give to another author. There are many times some people are analyzed for some people, they send to author and they raise some issue. We quickly try the issue, because there are some of them, valid, some of them, it shows their the reviewers' lack of understanding. So we won't say the person doesn't have you now explain everything and they take it and now understand. There are many cases like that, because the person that is reviewing may not have, we don't have the same knowledge in a particular area. It doesn't mean that the person doesn't know what he's doing. But that is, so if it's, and that is why they now, correct this one, they don't want to what can you explain why is this one like you explain, and some of them agree and you do. But in exam, it can be painful that somebody just fail somebody. When somebody has spent so much money, stress himself and the family to do the work, somebody just fail. And that's why I'm being careful when you advise people when it comes to exam. So I don't want to give categorical so that you won't say that's what I said. And okay, let's see the person come and pass you now. So
thanks very much indeed.
You're welcome.
Greatly appreciated.
Welcome. There are many questions. Let me quickly go and read. Don't ask questions now. I'll still give room. Let me quickly go and read those first questions I opened somewhere so that we can try them. That first chat. Okay. I'm not okay. Please, can the screen, somebody say the screen, I should zoom in. I think it's okay now. Okay. Yeah. Okay, it's about the screen now. Okay, somebody has a question. is the one sample t-test the same as one t-test? No, it's not the same. Where it's not the same. It's not the same, but one sample t-test can be a one t-test. If you remember, on Tuesday, I presented, maybe that was the reason you are asking that question. You know, I presented the normal distribution representing one t and two t-tests. I say for two t-tests, one t-test when the population is one is higher than the sample test, sample mean, or when the population is smaller, so it can be left or right t. You use it, but there are some situations also that you just want to know, is this value, is it the same thing as population? You have not predicted that is higher than the population value. If you already say, is it higher, what you are testing is that, is it higher than population value or not? Or you are testing, is it lower than the population value or not? That is one t-test. But if you just, is it the same thing as the population value? That is two t-tests. So that shows that it can be higher, the population can be, it can be higher also. The population can be higher, the sample can be higher, any of them. So a one t-test can be, it depends. They do it at one t-test or two t-tests. So the issue of one t or two t-test has something to do with maybe it is one sample t-test or not. Even a 2,000 sample t-test can be one t or two t. I don't know if I've answered. Fisayo, have I answered your question now? Okay. Okay. I think I'm done with that one. Let me now come back. So can you people hear it? There's echo. Okay, let me read.
Sorry, sir.
Okay, good afternoon.
Good afternoon.
Good afternoon. Go on.
The one sample t-test.
Yes.
Can you give example?
One sample t-test. Okay.
Example.
Okay, you got example. Like you want to, you say the blood pressure, you want to know the systolic, average systolic blood pressure in a group of adults, or maybe the average blood sugar in a group of adults, and you want to compare it with what is in that population. So, you know, maybe ABA now, they say that the average blood pressure, systolic blood pressure in ABA is 115. That study that have been done, which they publish. And you now do your own study, it's only one group also. You want to compare with it, that's one t-test. That is one sample t-test rather. That's one sample t-test because it's only one sample you do. The sample means the number you are dealing with. One sample t-test, you did one sample, you are comparing the value. And whereas in one sample t-test now, you have your own data set. You can calculate the average. Then in the other one, in the population, you don't have their data set. It's only the average that they publish you have. But in two samples, you have the two samples which you collected yourself, which you have the data set and the mean with you. I don't know if you understand. It's clear now. Is it clear?
The two samples. You said the two samples is what? When is the two samples?
You took two samples, like urban rural. You took two samples yourself. You took, you have two groups. You have two groups. You are, yes. And the two samples also can be paired. If it is paired, is from the same group of people before and after. You know, on two occasions you measure it. You take the measurement on two occasions, that's paired. The independent two, that are two group of people, independent. Somebody said, can we have a review of both linear? That was the multiple logistic regression. Does it mean the outcome are more than two? No, the outcome is only one for multiple regression. It's only the exposure, the independent variable that are more than one. That's the meaning of multiple. You know, that's a mistake. The people call it multivariate analysis. No, it's not multivariate, it's a misnomer. If you go and check good textbook, not all these square textbook, if you go take standard statistics textbook, linear regression, logistic regression, they are multivariable analysis. They are not multivariate. The meaning of multivariate means that you have more than one outcome variable at the same time. Example is multivariate analysis of variance, MANOVA. Then factor analysis, multi-dimensional scaling. Those are multivariate analysis because you have more than two outcomes, more than one outcome, more than one exposure. That's multivariate. But the one that the regression we are talking of is only one outcome, but you can have many exposure. Multiple regression is a multivariable analysis. But many people just call it multivariate analysis. Okay, another person.
Sorry, sir. Still on that.
Okay.
You said simple logistic regression is one outcome and one exposure.
Yes, what's making it simple is the exposure is one. You know, you already know that all the regression is the outcome is only one. But if the exposure is one also, that's simple. If the exposure is more than one, that's multiple.
Okay, but you said binary logistic regression is when you have
no, the binary is still one outcome, but the possible value of that outcome is 2. You understand that? It's just like discharge or not discharge. Discharge, yes or no. Discharge is just one outcome, but yes or no is possible. Is just one outcome variable, but the possible outcome of that one outcome variable is 2, either yes or no. That is what makes it binary. Okay, if it is yes or no, or yes or no, but probation, if possible something, that would be multinomial, because the possible outcome. You know, anything that follow binary, binomial distribution, the only possible outcome is if it's an outcome, is binary logistic, because there are only 2 possible values for that outcome. Like for a female, male and female now, it's only that most of the time, male and female sex is not usually an outcome, it's an exposure. If let's say something like that is an outcome now, so it will be binary because it's only possible value for that outcome variable. Examine now. Okay, let's exam. Either if it's either fail or pass or fail. If it's an outcome, if the possible value is either fail or pass, yes or no. This is binary. But if you have yes, no, I don't know, maybe question yes, no, I don't know. There are 3 possible value for the outcome. In that case, if it's multinomial, it's still this one only outcome. 3 possible value. That is it's not binary. It's called a multinomial. But if it is multinomial and the outcome are ranked in ordinal, they call it ordinal. So let me read other something. So somebody said to determine if a relationship between 2 variables causa when you are doing correlation. Does a correlation correlate? No, we cannot do correlation. There's nothing like exposure. You can't use correlation. So when you are talking of cause effect now, you now go to regression. Yes, Anna. Actually, to be sincere with you, the only place you can talk about cause effect most of the time is when you calculate, you do measure of association. You know, with some of these analytical study, like experimental, quad, case control, where you calculate odd ratio or relative risk, and even together with a lot of other things. Before you can say causa is causa, even the statistical significance doesn't mean it's actually significant. So there are a lot of things. I think I don't know if it's part of my. I will include it in my this judging association. How do you judge association? You know, measure of association. If the measure of association is it consistent? A lot of things. The quantification, the value of the association, is it consistent? Is it biological plausibility? A lot of criteria to judge if something is causal. But the fact that you did your own analysis, something is there's an association does not mean it's causal. But apart from that, the regression is one thing that you actually know if something is a predictor. Predict something doesn't mean that it's the common causing it, but at least it's closer to it that, oh, this one is a predictor. Because something may look like a predictor, maybe some underlying thing, it may not be the one causing it directly. So, but it can be a predictor. So, to really predict a particular value of a variable, use regression. Correlation is out of it. In fact, in correlation, there's no outcome, there's no exposure. No dependent, no independent in correlation. Well, how can you track?
But how can we use that? Sorry, sir. How can
Okay, let me answer Dr. Bello something. Can we have a review of both? Why I'm taking is because question would be why I have not taken it because some question will may clarify those things. So that's why I'm not repeating myself. I want people to ask questions. And I ask you if, with all these things I said, should I still go through? So Dr. Bill, are you still okay, or I should still go through? Because some people they've asked questions in that line.
I guess it's a bit clearer.
Okay.
Yeah,
So
the
outcome is the logistic regression. The outcome is continuous. In the linear regression, the outcome is logistic. The outcome is categorical. And the categorical, if it is two category, it's still one outcome. But if it is two category, that it comes the value of the outcome comes in two categories, binary. If it comes in more than two categories, is binomial. Multinomial rather, multinomial. If that multinomial is order, that is rank, like something that has grade, it's ordinal. So, and if any regression that has one exposure alone is simple, so that you can have simple logistic regression, you can have simple linear regression. If the regression has more than one exposure variable, that is multiple regression. You can have multiple logistic regression or multiple linear regression. And that is what they call, some people mistakenly call multivariate analysis. It's actually multivariable analysis. Multivariate analysis. Because one exposure, one outcome, many exposure, multivariable. So it's not multivariate analysis. But that's what people call it. So I think somebody saying, how can you track where there is a difference after analyzing category? Where there is a difference. Okay. Yes, I think that one is more when we analyze, you will see how, if you categorize something, you cross-tabulate something like age group, like the question Ugo now was asking. If you categorize age and you cross-tabulate with maybe urban rural, there's a difference. You may see that age group less than 20 in rural, you have a 30% there. Whereas less than 20 in urban, you have the percentage of the people in that category is only 15% of those people in that group. It shows you that in your study, there are somehow we have more of people of younger age group in the rural than the urban. If you now come, you see that the percentage of people greater than 60%, they are higher. Maybe they are 10% in the urban, and they are only 3% in the rural. It shows that the picture is telling you that more your sample, the urban people are older than the rural people. That's what you will see in the percentage. So in other things like ANOVA is a different ballgame. That one, I have to know where the different lies. It's when you get there. It's not something you can explain now. I think we are through. I think we can. If there's no other question, we can stop. So most of these things.
Hello?
Yes, go on.
Hello? I don't understand. Yeah, please. I asked a question. I don't know whether you saw it. I said, can you please explain to me the difference, if any, between Z-score and the standard deviation?
Sorry, yes, I saw it. I forgot. And standard deviation.
Yes.
No, the Z-score is a form of standard deviation. Z-score is a standard deviation. Is the number of, it's not actually standard, it's number of standard deviation that is Z-score. I don't know if you were around when we talk about normal distribution. Were you around?
It's been difficult accessing the internet.
No. Okay, you were not around. That's what I want to know. Now, I gave an example. I say, if the mean age of some group of people that are doing exercise, women that enroll in exercise, say their mean age is 20, in 70 kg. In mean weight is 70 kg. And somebody has 80 kilogram weight. Somebody has 90 kilogram weight. The person that has 80 kilogram weight, when you remove mean from it, it give you 10. And the standard deviation of them is 10. So the mean weight is 17 and standard deviation is 10. That's an hypothetical example. So if somebody weighs 80, his 80 is 10 more than the mean, which is 70. So when you divide that 10, which is different between 80 and 70, over 10, which is the standard deviation, it gives you 1. It means that that person is 1 standard deviation above the mean. Somebody that is 90 kg, if you divide the difference, which is 20, between 70 and 90, is 20. You divide by standard deviation, which is 10, it gives you 2. That shows that that person is 2 standard deviation above the mean. Somebody that is 60, when you remove 70 from 60, it gives you minus 10. You divide it by the 10, which is standard deviation, it gives you minus 1. It means that that person is 1 standard deviation below the mean. That minus mean is below the mean. The plus mean is above the mean. The person that weighs 50 is, you remove 70 from it, give you minus 20. Divided by 10, which is standard deviation, give you minus 2. That person that is 50 kg is 2 standard deviation below the mean. So you can see that value, 1 standard deviation, 2 standard deviation, is this score. The number of standard deviation above or below the mean is the z-score. And you see now, it's not standard deviation, it's the number of standard deviation. So you can express somebody's value, your age now, you can express as z-score. How many standard deviation are you? The age of adult in this class now is, let's say, in this class, the mean age is 35. And you are 30, and the standard deviation is 5. Mean age is 35, standard deviation is 5. And you are 40, you are 1 standard deviation above the mean. Yes, you are 1 Z. Your value, instead of writing on age, you need to be 40 here, just 1 plus 1. Somebody that is 45 is plus 2, because the standard deviation is 5. So anybody that is 5, 10 more than me is 2 standard deviation. Someone that is 25 is minus 2. Someone that is 30 is minus 1. That is so this is normal standard deviation. That's answer your question.
Thank you very much. Thank you.
Welcome. Okay, I think we can close here.
Thank you.
You're welcome. So,
Thank you. Thank you.
okay. Okay, I'm listening.
What is the essence of correlation now?
Correlation. Very plenty. You just want to know the degree of association. Something, some of this analysis is, if you get to know when you are doing serious analysis, it's more like screening. You first of all do simple things, it will lead you to that. When you get to regression, we do. If we treat regression, we know the essence of correlation. You get to know the essence. Since there's no exposure around, that's why you're asking.
Yes, I'm wondering then what is now the essence? I thought
I don't want to know. You get to know it later. You get to know. Okay.
Thank you.
Okay, welcome.
Thank you.
Okay, somebody say, can you do this slide on WhatsApp? No, you go to visit the slide will be on the website. Go visit the website. Somebody asks if you can drop the slide on the something. The slide will be available, even the video will be available on the website. I think I've given the website before. Let me type it.
No.
Well, I need it. The website. Leverage. Okay. Why am I sharing it with somebody? think we should.
Hello? Hello, sir.
Yes.
Well done, sir. Sir,
Uh,
please, is there anything scheduled for the weekend? Any lecture scheduled for the weekend?
yes, now it's posted in the training on SPSS. I send it. Okay, your number is on the WhatsApp.
Yes, sir.
Yeah, you can type the number now. We'll send the number. You can
I should type the number.
chat the number. There's a training going on weekend. You pay for it.
Okay.
If you send your number, I will send it to. I will forward it something to you. Tomorrow,
Okay, sir.
next tomorrow, and Sunday. You see the schedule.
Okay.
Just type.
Okay, sir.
What's your number?
This is the number.
Which number?
I'm typing it now.
Okay. And your name, because what I'm seeing beach. And I know you must have name.
Yes, sir. I'm Hajara.
Okay.
This is the number, sir.
Okay. Okay. I've seen it.
Thank you, sir. Have a nice day.
And you too.